Perfect. So far we have discussed about various different things in SOC, right? We started with basics of SOC, like what is Security Operations Center, how it is being useful, right? So yesterday team we did talked about SOC, what is SOC and all. So let me just basically give you our day two's agenda. So over here we are going to talk about SIM. Yesterday also, if you might remember, I mentioned that it's a heart of SOC, right? We'll talk about SIM architecture, right? We'll have a tour of SIM. It will be more of practical session, I would say. We'll have a tour of SIM where we will be having ELK Stack Primer, where I will just take you to the stack, what is stack, how it's being used. So there won't be much practical for ELK Stack. I'll give you certain cloud-based access over there where you will be able to see that you can register it up over there and you will be able to get your ELK stacks trial access up over there, right? Second, we'll talk about IBM Qradar up over there, where we will be talking about first of all the architecture of Qradar. What is the architecture? And then I'll be showing you a demonstration regarding Qradar, right? So we'll spend some amount of time to this particular introduction, and then we will be talking about a concept which is totally different from SIM. That is basically, I would say, traffic analysis with WireShark, right? And in the end, as usual, we will be dedicatedly giving our last half an hour for Q&A over here also. So today's content much might not be as much as we were having yesterday, but over here today we will be having the practical session where we will be practically seeking that how we do use Qradar, how do we use Wireshark and all those stuff, right? So we'll start now with the help of SIM, right? So let's start with SIM. So SIEM, I believe it basically consists of two different things, that is SIEM and SEM, right? So security information event, it does consist of two things, that is SIEM and another one is SEM, right? Combining both of them together, you can call it as an SIEM tool, right? So SIEM would be the part where log collection and report generation will fall under SIM, where you do have security information management, right? So you do just create reports up over here under information management and you do log collection up over there. SEM is basically analysis of events in real time and correlation of event. That's what SEM event management does, right? Event management is more of event and information management is more of logs and data, right? So overall, if we do talk about SIM, basically it's a technology or a tool which provides real-time analysis of security alerts which are generated by our hardware and applications, right? And we do basically use SIM to perform all the functions of SOC, right? Majorly all the perform functions of SOC. So that is guys what we do have up over here is SIM. Now people do say that SIM is a tool which can be used for correlation. Some will say that it's an investigation tool, some will say that it's a monitoring tool, right? So there are different things which are associated. So we can say that SIM overall can do everything in its potential which has been mentioned up for here, right? It can go for abnormal behavior, it can go for potential cyber threats, it can provide a central place to basically collect events and alerts, right? So this is what SIM can be, right? It basically it's one of the important part of the data security ecosystem, right? So that's what basically SIM generally does. So if I just talk about the SIM process, like the simplest SIM process, if I do talk about, it is something like this, right? We do data, collect data like from various sources, network devices, servers, domain controllers, firewalls, routers, switches, everywhere, right? Once we have collected the data, next we do is normalization. We do normalize that data. What is this normalization? We'll just talk about it little later down the line over there. Then we do have aggregation. Normalization and aggregation both can be in one single place. Then analysis and discovery would be there. So over here, what we will be doing is we will be analyzing the data to discover and detect the threats up over here, right? In step 3. And step 4 will be the part where we will be triaging the alerts to the organization. So this will be the part where we'll pinpoint the security breaches and will enable organization to basically investigate the alerts, right? So that's what a SIM process would do. This is like one of the simplest SIM process. So how does generally SIM works? So SIM basically does have multiple capabilities. So the primary capability is basically for the IR team that it is able to help us to do the forensics and reporting, and alerts basically are based upon the analytics that matches a certain or specific rule set, right? So that's what basically SIM does. It basically indicates the security issue within the system. It does have lots of capabilities apart from these ones, like these two are the major ones. Capabilities like it can do threat detection, we can do investigation with it, we can get time to respond, we can go for log collections, we can go for incident detections, threat response workflow, all these things we can do it via SIM up over there, right? Like there are lots of SIM tools, Splunk, IBM Qradar, Logarithm, RSA, Azure Sentinel, as we discussed yesterday, right? SIM helps in multiple different ways. Also, if I do talk about SIM, it does helps in multiple different ways, right? So where what are the use cases of SIM? So these are more of don't you guys think that these are more of like attack based use cases, right? Use cases of SIM would be that where SIM is useful for us, right? Of course we can do all these things, but majorly if I do say SIM can help us in compliance, right? Remember yesterday I mentioned compliance. It can help us to detect insider threats, right? By user activity monitoring. We can go for like behavioral analytics, UEBA, user entity behavioral analytics, right? It can give us the visualization of the data architecture. We can go for our other types of security like IoT security also, right? So lots of things are basically which we can do with SIM tool. So there are basically all these things which a SIM tool can do, right? So basic SIM process and functions of SIM are up over here, right? Now let's do talk about the SIM architecture. So I'll just basically, before we do proceed with architecture, let me just write a list of capabilities up over here. Since there are a lot of capabilities, I'm just trying to add couple of them up over here. So the first one would be aggregation of data. Data from various sources, collection of data from multiple sources. So aggregation would be where we will be collecting data from, aggregating data from many sources, be it our network, be it our security systems, be it our servers, be it our database applications, and so on, in order to create a consolidated view of data which can help us to simplify our monitoring. That's what. Next, I would say alerts. SIM basically can help us for alerts. So alerts, basically it will be generating a notification or alert for any type of security issue which is detected within the system. So in correlation, basically what we do is we look for common attributes, right? We look for common attributes and we link the events together into meaningful bundles, right? So this basically technology is what we do call as correlation. It provides us like multiple different types of correlation techniques are there to integrate different sources in order to turn the data into useful information. Just a small example, like I believe I have taken this example yesterday also. If your web application gives you certain log, if your web server gives you certain log, if your IDS gives you certain logs, correlating all three of them together in order to find out what is the exact issue, that's what correlation would be, right? So this is what we do call as correlation, where we do have common attributes which we to try to find out between different types of logs, and it links together into the meaningful bundles. So we do have retention, right? So retention would be the part where we our SIM will be able to. SIM basically does have features which can help us to retain our old logs or data for a long time to facilitate correlation of data over the time. That's what we do call as historical correlation, right? Even not just basically for correlation, but we can store the data for a longer period of time. That's what retention is all about. Apart from it, guys, SIM can provide us, like with this cloud native SIM solution, it is something which is becoming one of the again capabilities of the SIM, that is scalability. So scalability, there are two things, guys. The one is scalability, the one is elasticity. Anyone can differentiate what is difference between scalability versus, I would say, elasticity? So scalability and elasticity. So scalability would be the part where you are able to scale up anything which you do have, you can increase your capacity. That would be scale up. That will be scalability, right? Let's say you are having 5 servers. Now you are able to scale it at up to 10. That's what scalability is. Elasticity is if when I want, I can scale up. When I want, I can come back. I can scale down, right? So that's what elasticity is. It's just like elastic. You can shrink, you can stretch both, but scalability will be always one way. You can increase it. So SIM does not provide elasticity. It provides scalability majorly to us. Capabilities of SIM, right? Aggregation, alerts, correlation, retention, scalability. Parsing would be the part where, yeah, that is something which basically happens in SIM. So we generally either include it after the aggregation, normalization, or just before the correlation, we do parsing up or there. Reporting can be one of the features, capabilities which we can add up or here, which SIM basically does provide us. Reporting where we are able to create multiple different sorts of custom report, be it for management level people, be it for compliances, be it for audits, be it for scans. We can create multiple different types of reports up over there, so that's totally fine. We can include this one. So that would be an additional feature which you will be adding. By default, SIM does not have orchestration automation response. You do need to add capabilities to your SIM, then only it will be having up over there. Yeah. So let's keep it this much, I would say. These are like more of the I would say normal ones which might apply to every sort of SIM solution, right? Rather than a single or a specific type of SIM solution, right? So this is basically like few of the SIM's capabilities. Now the question arises, why do we need SIM? So let me just conclude all these particular answers into some of the key pointers up over here, right? Like I would say rise in data breach due to internal and external threats. So we can go for tracking these internal and external threats with this, right? So rise in data breaches happened and internal and external threats, we can track it via SIM. How we can track it? For external threats, we do have threat intelligence being integrated. For internal threats, we do have user activity monitoring, right? User entity behavioral analytics. Absolutely bird eye view. Now attackers are getting smart, isn't it? That's why also we do need SIM. Attackers are smart. Our traditional security tools just don't suffice, right? So that is again also one of the use cases. Again, to mitigate sophisticated cyber attacks, then after mitigating sophisticated cyber attacks, we can say to manage increasing volume of logs, yes or no? Because logs are being generated from multiple sources these days. So volume of logs from multiple sources. Like if I just do talk about a single firewall, external facing firewall, it can generate thousands of logs in just couple of minutes, right? So that is something up over there to meet stringent compliance requirements. So these are the things which we can say that can be the part where we can use this particular sim solutions, right? Like these are few of the things, and of course the points which you guys have added, like malicious activities, infra related events. So these can be the cases. We can go for like incident management up over here. Sim can help us to do that. That would be more of the need of SOC. Entire incident management cannot be done only via SIM, but yeah, it can help in incident management process, right? So these are like few of the use cases. Why do we need? All right then. So next we'll be talking about SIM architecture, right? So I'll just bring up a small image up over here, which will be the simplest form of SIM architecture, which we all can relate to. So have a look on this particular architecture, guys, and let me just explain you all how does it works. So we start with collection, right? Where log data from multiple devices like your firewalls, routers, switches, your endpoints, your web servers, your endpoints, web servers, your we can say data centers, like from your network devices, from every sort of area you will be collecting all the logged data from all of your these particular devices for analysis and investigation. You are collecting it to one centralized space. We do have push method, we do have pull method, syslog, absolutely yes. We do have agents, right? We can use syslog, right? So there is push method, there is pull method. So let's say endpoints, basically we can install an agent, right? Which will be collecting the logs and will be pushing it to our SIM solution. So that's a push method, right? Agents will be pushing logs to our SIM solution. Now on my firewall or on my router, I cannot install an agent, right? So I need a agentless communication. So what I do is I pull the logs via syslog server from these particular devices, and from syslog server then it is being pushed to my SIM solution, right? So that is something which we can say is pull method. So SIM basically will be collecting all the logs from different sources from both of these particular methods, right? We will be having both of these particular methods over there. Next one is normalization. Okay, so normalization will be not just only doing the CEF common event format. Of course, it will be, since we are collecting the logs from multiple different sources, right? And while we are collecting the logs from multiple different sources, we need to basically make sure that all the logs are in a particular format which SIM can basically understand, right? So what we'll do is from different formats, we'll convert them to common event format which our SIM will be able to understand. First thing, we will be apart from it, we will be removing redundant log event entries, right? Redundant event log entries which are collected from thousands of these devices are being eliminated, and our collection is being made more precise up here by creating these particular formatting and then removing the redundancy from these thousands of logs, right? So that's what happened under the normalization. Clear? Right after that, guys, we do have correlation. So correlation would be the part where all these redundant data which has been logged is being looked in for some common patterns, and based upon the common patterns from data from different sources, we find some link between them so that we can use that particular information, right? So that is something which will be the part of correlation. Clear, team? Next is database. So database will be the part where logs will be retained within the SIM, right? Logs will be retained within the SIM solution. This will be the part up over there, right? If they are not quickly processed by the server, they can still be there within the SIM waiting for their chance to get processed. And generally the retention period of SIM goes around like is 30 to 90 days, right? And if you want to hold it further more than that, you can go through the storage part. So before that, once you are in database, reporting is there. So reporting would be the part as we already have discussed, so won't take much time on this. So all the reporting events and incidents in detailed reports, we will be creating metrics reporting where the current security posture of all of your network devices will be shared and will be uh, generated and shared with your senior management for decision making on, let's say, security investments, and these reports can be sometime used for purposes like compliance and all different sorts of purposes. So that's your reporting. And storage is basically the part where you will be storing the event logs for longer period of time, for longer period of time for your future reference to facilitate correlation of data over time. All these things you will be having it up over here on your storage part, and you will be integrating it with your SIM solution, right? So historical correlation, you can use it if you do have one. storage being implemented, right? And if your logger is implemented between this storage and your database, they can basically store and retrieve data from long period of time. So that is reporting. Next is notification. So notifications are nothing but alarms, right? These are the alarms which are raised in real time when a particular, let's say, predefined rule are not met or rules are matched, right? So if I say that if you find this, give me the alert. So at that time, notifi notification would be there. And we can also find notification at the time where we are trying to get what predefined rules are saying, right? So if they are not matching, like for example, external IP, your external IP, you're having a request, a traffic from external IP to your internal IP, but on multiple ports. Like port 80, there is traffic, port 443, there is traffic, port 22, there is traffic. From same IP, port 25, there is traffic, and so on. So what do you think? What this type of activity is when an external IP is trying to communicate you on different IP? I do have a rule where I do say that an external IP to multiple ports on our network should be denied, right? And if this does not happen, matches, that means an alarm will be raised if this type of activity will happen, right? So that's what basically a notification is all about. Clear, team? So that is basically your simplest SIEM architecture. So does SIEM basically stores raw logs or parsed or normalized logs? So it depends on SIEM to SIEM, right? If you do talk about Splunk, it parses the logs and then it stores the logs, right? If you do talk about Qradar, unlike Splunk, Qradar does not index every particular log source, right? So some of these particular events will be parsed, normalized, and then stored, and some of these might not basically being parsed. They will store it as a raw log. So it depends. In Qradar, you do have options that which particular properties you want to index upon, and accordingly, it will be indexing those particular properties itself. Pull method. Okay. So pull method would be the part where this is my device and I want the logs out of it. So what I'll do is I'll have a syslog server where I'll request this particular device to reply back with all the logs, right? So I'll just collect this particular part. So that is basically what we do call as pull method. Generally, you can see it API methods where an API basically makes up multiple requests to your server to basically give back the data, right? And your server responds back with the data. So that's what pull method is all about. There are different architecture. Like if you just go on internet and you see there will be different types of architecture altogether. You will be able to see every different like vendor would be showing different architecture to all together. But this is something where you can understand the entire SIMS workflow in a simplest manner, right? So this was guys all about your. Now we will be shifting towards the tour of SIM. We'll be talking about multiple different SIM solutions, right? So we'll be shifting towards that tour. So let's start with ELK. ELK Stack Primer. So this ELK stack is built up of three open source, I would say, tools that is summing with the name of ELK. E is for Elasticsearch, one of the most famous of Elastics, right? Like one of the most famous of ELK built, Elasticsearch. L is for log stash, K is for Kibana, again one of the famous ones, right? So three open source tools, when fully assembled together, it will be allowing any user to analyze the data from any type of source in any type of format, right? And as compared to another log analysis tool, this ELK stack is known again for its dashboard, its visualization, which can present a very complicated data in very sophisticated and simple manner, right? So that is what ELK is all about, right? So originally Elastic Stack was the abbreviation of these three main components only: Elasticsearch, Logstash, and Kibana. And the name of the stack was being updated when Elastic just launched one new thing, that is B, Beat, right? When Elastic's Beats was being introduced as one of the fourth components, now they do, some people do call it BELK, some do talk about BEK, right? So it's basically Elastic company, the stack, I'm talking about the stack itself. The stack was being created by the company Elastic in June 2012, right? 2012. But this Elastic, this Logstash, and this Kibana, all of them are the products of early 2000s, where multiple different people who were working on different products like Elasticsearch, Logstash, Kibana worked together and decided to unite it, and then in 2012 ELK stack was born, right? In 2015 Beats came into the picture, right? It is basically your shipper, right? It can ship any type of data, including your audit data from Linux systems to your event logs in Windows systems to any log data that can be forwarded and centralized. Beats is easily able to forward that particular data, right? So be it your OS and service matrices, service status data, network data, cloud data, in any sort of environment, serverless environment and all sort of environments, Beats is able to collect and ship that data from one point to another, right? So Elasticsearch, Logstash, Kibana, it works it in this way. It's basically a belt, a stack up over here, which runs on different parts, right? Elasticsearch, just a quick overview, it's a JSON based RESTful distributed search engine that can be used for searching and indexing files in different multiple formats, right? So I'll just write it up over here. This is basically the indexing. This is the brain of Elastic Stack. So indexing and storing data would be the part of Elastic. Then you do have Logstash. So Logstash is basically just used as a ingest pipeline to collate, to normalize, and to distribute logs. We do use Logstash. It's a kind of aggregator, right? So over here we do basically, so earlier Logstash was one who was responsible for collecting the data, but now we do have Beats, right? So we do not use Logstash anymore to collect the data. Earlier Logstash was one which was ingesting the data, that means collecting the data, normalizing it, and was distributing it to SIEM or any other product where we do want. Third one is Kibana. So this is basically something which is being used for data visualization. Elastic is basically your CLI based. So your graphical representation, data visualization, analysis, and reporting would be the part of Kibana up over there. Clear? Then team you do have Beat. Now Beats, as I mentioned, are your data shippers which complements the stacks, right? So they will be allowing or collecting data and will be sharing it to your. It can either share it to Logstash if you do have Logstash. If you do not want Logstash, it can directly share to your Elasticsearch as well. So that's what guys Beats is all about over here, right? Now can you guys see up over here? You do have Beats which is installed in the end system where data is being collected and sent to Elasticsearch, where it is being indexed and stored, right? And once it's being indexed and stored, the data basically we can use it for Kibana for visualization, for reporting, for we can say visualization, reporting, creating custom dashboards, all these things we can use Kibana for. Even for analysis also we can use Kibana for there. So this is guys your ELK stack based upon one on one. Each stack is working similarly. Clear? And the best part is it is one of the most popular open source stack, right? So people are using it as a SIM solution. They do call it Elastic SIM. So Elastic SIM, as we do know that it's the key component of SOC, right? So Elastic basically offers a SIM tool which is being designed to make alerts, right? Which is being designed to make alerting and reporting bit easier. So Elastic SIM will be providing network and host data integrations. Elasticsearch basically it does what is it basically provides the network and host data integrations. It provides shareable analytics. It provides your ability to explore most of the security data with its SIM app. So what it does have Kibana, right? And security teams basically can use this SIM tool to monitor threats, gather evidences, which can help in investigation, right? And as an analyst, it is basically important to be aware about Elastic Stack's capabilities, isn't it? Because from the analytical perspective, if we are aware about analysis is basically the main focus of every SIM, right? Next we do have is Kibana. So Kibana, as the name, as we already have talked about, this will be something which will be helping us in visualization, reporting, and all those stuff, right? So that would be Kibana, where we will be able to visualize, we will be able to go for the reports, right? And Kibana basically works on one query language that is KQL, Kibana query language. So if you are familiar with SPL, Splunk's SPL, search processing language, it is basically similar to that Kibana query language. We'll do that a bit practically, right? So I'll just show it off to you up over here. So let's do a small demonstration for that, right? So let me just basically take you to the Elastic. So this is the Elastic's website where you will find the entire three components of Stack. You can download all three of them and you can use it as a SIM solution. Try to basically create a habit to use this one in your home network at least, right? So products, like if I do come up over here, enterprise search, observability, Elastic Stack, where we do have SIM, threat and all these things. We do have Elasticsearch and Kibana, the ELK stack. So we do have multiple tools to download. Elasticsearch we can download Kibana up over there, right? So multiple things we can download it over there. Then we do have this elastic security where we do have SIM and security analytics. We do have endpoint security, right? So let's basically go for a trial of SIM. So they do provide a trial of SIM, cloud-based SIM solution and security analytics. So let's give it a try up over here. You guys can also basically go up over here, register on this and get your trial up over here. Yep, so we are over here. Now let's create our first deployment. I'll give my deployment's name is ELK, right? And I'll create deployment. My username is Elastic, my password is this, my deployments are being saved. Give any deployment name and then it will be creating your deployment up over there, right? So it might take couple of minutes for you. So meanwhile, you can do that stuff. Like everyone can give it a try. It does have 14 days trial. You can use a temporary mail account in order to basically get your deployment done. Meanwhile, let's verify our. So it will take like just couple of minutes. Let it basically bring and then we do start up over there, right? So meanwhile, you guys can also create an account on Elastic Cloud and let's have a quick overview. You guys can also see yourself up over there. So once you do visit this particular link, what you need to do is just click on this start free trial and it will be basically taking you further ahead. So you guys can see that my deployment is ready. I'll just continue upon this part. Now it says that welcome start by adding integrations, right? So we can add data from multiple sources. We can visualize them in real time, right? So let's say we do add integrations up for the endpoint security data. If we do have any endpoint data, we do have website crawler, APM, all these things. So these are the integrations which you can integrate it with this tool. So as of now, we do not need integrations for sure, right? So let's go for an enterprise search where we will be able to do search on the data, right? So just one second, guys, just one second. So over here, we can get started. We go through the discover part and we can see the dashboard also, right? So it says that welcome to analytics, add integrations. If we go through dashboard, create your first dashboard up over there. It says that new to Kibana, add some sample data to test the drive, right? So let's do add some sample data to Kibana. Now this is sample e-commerce orders data, sample flight data, sample web logs. So let's say we do add sample web logs up over here. So sample web logs are being installed. So now if I go through my dashboard, you can see I do have this sample web logs up over here where I can see all the web traffic logs up over here, right? Now over here I do need KQL, Kusto query language, sorry, Kibana query language in order to basically query out the data to this particular dashboard. Now see up over here guys, you can see dashboard. This is something which the sample data is automatically creating, right? We can see all these different types of data up over here, like the data which is going up over here, all these sample data we can see up over here, right? So this is something which is dashboard is being creating itself, right? If we go through the discovers part, this is where we can see the raw data, right? Now you can see index. Over here there are these different sample indexes. Just a sec, let me bring it up. Right, so now you see up over here, this is the timestamp, this is the agent, this is the client IP. Now let's say I want to sort the data via client IP, right? So I can just click on client IP up over here and my data would be sorted with the help of client IP, right? Now client IP has been selected. So I can see at every timestamp, I'm just seeing this particular client IPs itself, right? If I do remove this, you can see all these particular things where there is the sample web logs, coordinates, right? Now over here you can see all the fields which are being extracted by this data set, right? You can see agents, you can see event data set, you can see extension, geo data set, host, IP, machine OS, RAM, memory, message. Now this is message. That is something interesting. So let's have a look on our message part. So this message has been added. You can see these different types of messages are being added. Now you can simply put a query up over here where let's say client IP is equals to, you can give your own client IP, right? Let's say I do give my client IP 110.47.202.158, right? And I do search upon it. Now you can see all the logs related to this particular 110 are up over here, right? So total number of hits I'm getting over here is one on May 20th, one up over here, and one up over here. Three different hits I'm getting up over here. Understood, team? So that is how you can add multiple different types of data. Now, let's say I want to extract URLs out of it. So this is the entire URL which they were trying to extract. Now this is Kibana Windows XP zip, right? Elastic.co/downloads. This IP was trying to do that particular part. Understood? Now, I would say URL.keyword. If I want to have a certain specific keyword, I can search it up over here. Now you can see all the URLs which are being accessed up over here. Understood? So this is how your discovered field would be looking like. You can see all these URLs up over here. If you want to extract something else, you can just select that extraction and it will be showing you specifically that particular extraction up over there. Sounds good. Now I want to see for each URL what was the response, right? So you guys can see it up over here. For each URL, I can see the response up over here that whether it's 200 or not. HTTP status 200 means success. Now over here, there was this URL which someone was trying to visit. It says 404, page not found, right? Rest you can see mostly are 200 ones. So that is how something you can see all the response, logs, activities up over there. And from the same activities, if you want to create your dashboards, you can go through dashboards, right? So we have so far added web traffic, right? So far we have added web traffics. We can add more different types of sample data and we can analyze those particular sample data up over there rather than this one. So how do you read the data? It totally depends up over there, right? So let's say I do select a country up over here, US or something like that. I do select the country US. My OS is, for example, Windows 7. So it will be refine the results accordingly for us, right? It will try to find the results. Can you see 343 hits are there, unique visitors up over here. You can see response for those particular unique visitors, log machines from which geolocations they were trying to visit. All the data we do have it up over here. Which particular URL they were trying to visit. So all these things. Understood? So that's what basically your dashboard is all about. You can try again some different sort of sample data. Let's say this e-commerce orders, right? So I want to add that data. Let's add it. And let me just remove this one. I do not want URL and response. I want to see the entire data set. Now there are women shoes which does have currency in euro and all these things, right? So now over here I can see different categories. Let's say I want to see all the categories. There are women shoes, men shoes, all these categories I can find it up over here, right? Now I want to see all the event categories which does have men's clothing, right? So you can see all the event categories which were having men's clothing are being highlighted up over there, right? So that's how it basically works. Like 457 hits are there of man's category. I can see from which location these hits are. If I go for like GIP location, I can see the GIP location. I can see from which emails I have get I got most of the hits, right? For which category, which emails I got hits, what was the day of the week when mostly I did got hits, what sort of products were there, what sort of product values were there, right? Let's say product ID I do add. So it will show us product ID, SKU, which particular user were doing it. We do have different names up over there, right? Over here, let's say I want to see a purchase of specific user, Rani, right? So I can see all the purchase of specific user Rani. I'll just remove all these particular stuff. Now I do have 29 hits for Rani up over here. So for Rani, I want to get the email address of Rani. I can see Rani's email address, something like this up over here. Let's say for her, I want to collect customer ID. This is the customer ID for her. From which city? Kerao, Kero. Like what is the product ID she's trying to get? What's the product SKU? Product quantity? So all these details we can easily get it up over here, right? So this is something which Elastic search, and Kibana basically helps us, right? What Elasticsearch and Kibana basically helps us, right? So you can just have a look on this one. Over here also you will be seeing a dashboard. You can create your own custom dashboards up over here, right? So this is the dashboard over here. Now you can open this one, you can create your own dashboard. You can select the type, what sort of dashboard you want, right? We can add our visualization up over here. So let's say category, products category equals to jeans. For example, if there is jeans, I'm just taking a guess. So if there will be anything, it will be showing us the results to us, right? So that's how basically it works. You create your search results and you do get your data up over there. So you need to select which dataset you are going for, and accordingly you can create your own dashboard. Now this is something which is already being added, a revenue dashboard. So sum of revenue, total spending, all these things you will be able to see, transactions per day, average sold items, right? Transactions per day, all these data and details, you do get it up over here. Yeah. So what you can do is you can just go through home. On home, if you scroll down where integrations are there, it will ask you to try sample data, right? So click on it. You do have three different types of sample data which you can add and remove and see the things up over there, right? So this is the sample web logs which I added. E-commerce order second one, and flight one you guys can have a look on this one. So over here also guys, let's say in integration, let's say if I want to integrate it with my Alien World OTX, right? So I can integrate my Alien World OTX pulses up over here. So for this, it will be asking me the name, the description, what will be the time, how like every 2 minutes I want to basically collect the logs. I want to give the API token. Let's say every 1 minute, I will just give, I do have an OTX account, so I'll just give an key up over here. 1 second. Let's keep up the default options. Let's try to add the API to our OTX. It might take a minute or two, so let it happen. So you can see my involved OTX integration is added. So to complete this integration, I need to add an Elastic agent to one of my hosts where it will be collecting data, right? So all I need to do is just take this Elastic agent and install on one of my hosts, right? And once I will be, this agent will be collecting the data. This is basically, let's say I go for Windows, and for Windows, let's do it, right? So let me just copy this entire part. So now what will happen is once I basically download this Elastic agent, right? So agent one policy where I will be installing. So what will happen? It will be collecting the data. This Elastic will be collecting the data from my that particular agent. It will be collecting the data, and with this threat intelligence, it will be monitoring all of my threat feeds up over there, right? Like whatever my threat feeds are, it will be monitoring those threat feeds up over there. Understood? So this is guys overall your entire Elasticsearch up over here. You can give it a try. It's a pretty nice, I would say, open source tool with where you can practice a lot of stuff, right? So that is all about Elastic now. So far we have talked about Elastic Stack, right? So now we'll be starting with IBM Qradar, right? So IBM Qradar, as I promised, we will be talking about first of all architecture, and then I'll take you to the very nice, decent demonstration of IBM Qradar. So be active, ask as much as questions as you want, right? And enjoy the session, I would say. So let's continue. IBM Qradar. IBM Qradar is one of the appliance. It's not just a software or a tool, but it's an appliance because it does requires a whole lot of system, and it itself is a system which will be used up over there, right? So to use Qradar, you do should have basic knowledge of Linux, right? Basic knowledge of networking, log collection, and all these things, and basic Qradar concepts, right? So I'll just make that Qradar concepts for you all, right? So let's do talk about it. So we do have in any sort of SIM solution. Yesterday we did discussed about analyst, right? We did discussed about admins. We did discussed about engineer architects. So we do have SIM admins also. We do have SIM analyst also. We do have SIM engineers also. So all of them does have different work, right? So let's start with the IBM Qradar component. I'll just bring an image up over here. Just give me 1 second. So these are all what we do call as IBM Qradar components, right? So these are components. We'll talk about this entire component architecture. Just give me 1 sec. This is our component architecture. We'll discuss each of them one by one. We have the user up here. We do have console. We do have event processor, event collector, logs. We do have flow processor, flow collector, vulnerability scanner, data nodes. Each of them will be talking about over here. So that's totally fine. Let's start with one by one, right? So let's start with event processor. In Qradar, we do have multiple different things. So let's do start with event processor. So I'm just telling you guys the inner working of the component architecture of IBM Qradar up over here, right? So IBM Qradar, it's one of the SIM solution, market leading SIM solution, and it does have lots of things which it can do at its end. and we will be seeing that practically as well. It can perform cognitive analytics, network flow analytics, it can perform your multiple different types of activities, like it can do deep threat intelligence analysis, all these things Qradar can do up over there, right? So there are basically certain tools of Qradar which basically does different works, right? Like you do have Qflow, you do have Vflow, right? You do have QRM, you do have QVM. Qradar Risk Manager, Qradar Vulnerability Manager, right? So these are the components, like these are the tools or softwares, or you can say virtual architecture which are available with Qradar. So when you install purchase Qradar, you can purchase these things also up over there. We'll talk little later that what all these things are, what useful, where do we use these things. First of all, let's do talk about Qradar's components up over here. Like in the background, how does Qradar works, right? What this is, guys, your Qradar's architecture up over here. So a high level architecture, you will be having something which you will be saying as collector, which will be having a processor, which will be giving it to your control, right? So in layman's language, this is your endpoint systems, right? From which you are collecting, we are collecting the logs via event collector. Event collector, once collecting the logs, is giving it to processor where correlation, normalization is happening, right? And once it does have that particular part, it sends it to the console, that is the front end UI of your server, right? So that is how it's working. Let's discuss it one by one, each of them. So let's start with event collectors. So what they will be doing, event collectors, they will be collecting the events from the log sources. What else they will be doing? Once they have collected the events from the log sources, they will be normalizing the logs, right? They will be bundling up similar events. What is the concept of bundling up similar events? Aggregation or correlation, bundling up similar events. So if I do say bundling up all the events, that would be aggregation. Similar events would be correlation. But over here, Qradar is basically performing something like this. It collects the logs from multiple sources, right? It normalizes the logs and then it bundles up the similar events. That means it's not correlation just now over here. It is having something which is a feature which we do call as Cole's King. Now this is basically a feature Cole's King where all the similar events within 1 minute will be bundled up as one single event, right? In order to save your licensing, like events per setting per second kind of things, right? And then it forwards the events to the event processor. So event processor is already receiving what sort of logs? It is already receiving normalized logs. Clear? So processor, once it does have the normalized log, what it will be doing? Once it receives the normalized logs and the raw logs from the collector, what it will be doing? First thing, it will be storing the data. Processor can store the data inside themselves itself, but if you do want to basically use processor for only processing, and you can use an external data node which can be used for storing your data. So this is optional part. If you do not have, processor will store it within itself, else it will be storing it in data node, right? You can store the events. Then this is where correlation happens. So over here, will correlate with other events, will correlate with information, other information up over there, right? Then what we'll do, will basically identify behavioral changes or any policy violation before going itself. This is where Qradar's rule engine kicks in. CRE, custom rule engine, kicks in, and it basically sees the work of Qradar. So that custom rule engine will be doing what? Every single event which is there, it will be checking all the enabled rules on those every single event. If any rule matches to one of the events, it will basically distribute that information to different parts, right? Like there are components. Let me just bring up one good image which will be giving you the entire idea of processor. 1 second. Yeah, so this is, guys, you can see another one for event processor. Now from event collector, once it has collected the logs, event processor will be receiving all the event logs. There will be an overflow limit where license limit will be checked, right? So license limit means in Qradar we do have licensing in two formats, right? So I'll just write it up over here. In Qradar we do have licensing in two formats. The one we do have is EPS, events per second, and another one is FPM, that is flow per minute. These things, events per second and flows per minute. So over here EPS licensing will be checked, right? And flow licensing would be checked. Once we do have enforced, every single event will be going through your custom rule engine, right? Every single event of yours will be going through custom rule engine, that is CRE. And this custom rule engine will be doing what? It will be testing all the enabled rules within your Qradar. Qradar does have enabled rules. So it will be testing all the enabled rules within your Qradar to see if any violation or any activity has happened or not, right? So if it matches, it will apply exit filter and it will share it to magistrate, right? That particular violation, it will share it to magistrate, and then events are being stored. Remember I mentioned events are being stored. So events are being stored on event processor, and when this storage filter applies, the events are then stored in one particular database which we do call as AQL database, or I would say aerial database. So we do have aerial for events and flows. First of all, you should guys know what is event, what is flow. So all of your log activities which you do have comes under event. All of your network traffic comes under the flow, right? Network activity comes under the flow, and logs comes under the event, right? So to store logs and event like logs and flows or events and flows, we do use aerial database. For all the front end, we do use Postgres, right? SQL. We do use Postgres SQL. And the third one is SQLite. Absolutely correct, Mr. Pankaj. We do use SQLite, where third party applications which we do install, right? So all the third party applications and their data is being stored, right? So these are the three databases which Qradar does uses. Now guys, event collector, after collecting the logs, give it to the processor. Processor basically test it against the rules and basically send it to the magistrate. Data is being stored in your aerial database, where anomaly detection engine will be looking into the patterns of attacks, right? Like a person from last 1 month is logging from morning 9 to evening 5, right? But all of a sudden he logins 3 a.m. midnight, right? And deletes certain files. So that is an anomaly which will be detected, right? So these sort of patterns, this anomaly detection engine will be detecting. Now let's say there is a event, guys, which is there's an event which was being discovered. A new device was being discovered, Cisco Talos or Cisco ASA device was being discovered. So as soon as a event comes up where there is a new host or a new port being detected on an existing host, host profiler updates that same thing, right? With every new log, the host is being checked whether it's the existing host or it's the new host, right? If it will be no new host, profiler will be creating a new host profile, and if it will be an older one but a new port will be discovered, a new port will be added to that particular host profile, right? So that's how your event processor works. Now same thing applies with the flow also, right? Which you have seen. Event collector, event processor. Flow collector will be collecting the network traffic, and after collecting the network traffic, from where it will be collecting the network traffic? From your network taps, from your span ports, from your net flows, from your V flows, from your Q flows, right? These are the all the flow collectors where it will be collecting the flow traffic from, and once it has collected that particular flow traffic, it will be normalizing that particular flows, and then it will be forwarding it to the processor. Once processor receives the normalized and raw flows, it will store it maybe in data node if not present in itself. It will correlate with other events and flows. Will again CRE will be there, which will be checking the behavioral changes or some sort of policy violations, and then the information will be distributed to magistrate, to your database, to your host profiler, all of them over there, right? So that is up till the part of processor. Now next is your console. Now once processor basically does have the data, it forwards the data to the console. Console is your front end UI, your user interface, where you will be managing all the other hosts. You will be seeing your real-time events, flows, and offenses, everything up over here. So we as a user analyst, we would be working up over here, and this will be basically having your tools like vulnerability scanner. It will be having other different things as well, right? So the magistrate, remember I mentioned magistrate, where if something matches to CRE rule, it's being sent to magistrate, and magistrate basically create an offense. Offense is basically what we do call alerts in Qradar. So Qradar has given a fancy name to to alerts. That's what they do call as offenses, and these offenses are being managed by magistrate, one of the components of Qradar, which is responsible for processing all the components regarding the alerts. So on this UI, you will be having reports tab, you will be doing the alerts analysis, you will be creating custom rules. All these things will be the part of this UI only. And this vulnerability scanner which you are seeing, you can see that particular vulnerability scanner on your front end UI, and you can actively scan your servers for vulnerabilities. You can scan your server for providing vulnerability information for correlation or any configurational parameter as well, and user will be accessing this particular part itself, right? So that's how guys Qradar basically works. Now let me take you to the front end UI of IBM Qradar up over here. So that's how your IBM Qradar looks like. It's a community license version tool. So that is how it looks like. Now over here you guys can see the dashboard, right? So I'll just give you a quick overview of this entire tool up over here. So we do have dashboard up over here where we can see multiple different activities like top applications which are collecting the logs, services which are being denied by the firewalls. We do have offenses up over here. We do have severe offenses, that means high alerts. So you do have application overview. Let's say you want to go for system monitoring. You can monitor your top log sources up over here. From your logs are being collected. Your EPS per minute per second average. What's the EPS average? Right? Because if EPS exceeds, Qradar will be not accepting that data until and unless the EPS comes back to the normal, right? So the data which will be coming while EPS is overflown will be stored to a buffer memory, and then that buffer memory will be forwarding the data to QRadar, right? So you do have different types of dashboard up over here. Like this is threat and security monitoring where you can see about all the threats and all these particular parts up over here, right? You can see all the offenses, top network sources, all these things. Next one is your offense tab. So offense is basically something which we do call as your alerts tab. So you can see there are these number of alerts which have came up over here, right? This is your log activity where you will be seeing all of your events coming up to the QRadar, right? You can see this API request, it's been managed, informational messages are coming from the server itself, right? QRadar server itself. If you look around in the network activity, it is collecting the network traffic, right? Then these are the assets, guys. You can see all these assets which are being added up over here. You do have the reports, different types of reports which you can generate. Remember, I mentioned that SIM does provide us like compliance based reports. Can you see PCI compliance failure reports, weekly PCI compliance failure reports? You do have IDS alerts, top malware activity, all these reports are there. This is majorly your admin tab. So in most of the organizations where you will be working, you won't be having this particular tab until and unless you do have the admin role, IBM Qradar admin role with you, right? So this is where most of the administrative tasks and functions can be done, right? So this is where this can be done up over there, right? So remember we did talked about retention period and all. So you can see all this information up over here, like over here in system settings, you can see how long the data is going to store, like database retention period, it's 1 day. Search results, for search results database setting, offense retention period, it's 30 days. So different things, you can just read it up over here, you can see it up over here. You do have your system and license management. You can see the default community edition basically comes with this particular event rate limit, that it is coming with 50 EPS and 5000 FPM per minute, right? This is the licensing which it is coming with. You can see it up over here, 50 EPS and 5000 FPM. Apart from it, remember I mentioned guys that Qradar does not indexes unlike Splunk. It does not index everything, right? So you do have index management up over here where you can see that what things are being, all the green dots are being enabled as indexing for the Qradar. So Qradar maintains an index for these particular properties, but not for every property, right? So that is what something you can see, right? So like this, there are lots of different administrative functions which can be performed up over here. So this is IBM Qradar over here. If you do have a vulnerability scanner, since community edition does not have vulnerability scanner, you will go and adding it up over here. It will give you the application error, right? But in a paid version, you will be having vulnerability scanner up over here. These are the licensed one. You can basically integrate it, right? Like my organization, let's say, uses Nessus. So whatsoever Qradar is by default coming with, I can remove that and I can add Nisa support there. So this is something which I can do. But what is the default one which QVM, that is Qradar Vulnerability Manager, is using? So this is about your Qradar up over here. You can see most of these things. Now I'll show you a small thing up over here. Like log activity will try to push certain logs. Before that, what I'll do is I'll just stop these ones so that I can just remove these ones from over here, coming up over here. All you need to do is just right click, filter on event name, which is not information message. So it will filter on the event name where there is no information message is coming up. Can you see? It seems to be that logs are stopped coming. Now I am having search completed. I'll remove this. I'll having search executed. I'll remove this. Search deleted. I'll remove this. Right. So these things have been added up over here. Now what I'll do is I'll connect to my Qradar CLI up over here via my SSH putty, and I'll just log in into my CLI of Qradar, where in one of the directories temp I do have a demo log folder up over there. Now over here you guys can see that I do have various different types of logs, right? You can see I do have Blue Code proxy log, Cisco ASA traffic log, McAfee antivirus log, McAfee sys log, Microsoft IS server logs, Postgres log, right? Snort logs, SSH logs, VPN logs, lots of logs are there, right? So we'll choose one of the files to push it to Qradar, right? So there is one script which is within the Qradar, which is in this location, opt bin logrun.pl hyphen f will give for the file name, and we'll choose this SSH auth over here, and we'll give this particular EPS up over here. So I do know that my EPS can handle up till 50. So I do not want to give more EPS like 20, 25, 30 or 50 because it will be very quick and fast. I want you all to see the changes coming up over here under the event name, right? So I'll just press enter up over here and you will see it will start collecting the logs over here. Can you see root logon failed, user failed to SSH, all these things? So these are coming because it is generating these particular messages. Now you can see all these event logs have been added. So why exactly it is coming failed? Let's see what was inside this SSH file. So that's what SSH file was having. It was having failed password for user admin. It was having failed password for shadow user. It was having failed password for illegal user test. All these things. So that's why fail results were coming up over here, right? Like user failed to log in SSH, user incorrect password. So you can just see that particular event and you can try to read more information out of it. So guys, that's how basically we push data to Qradar. Now with these particular like failed login attempts and all these things, there are certain offenses which might have been generated, right? So let's basically clear out the filter up over here and see if there are any offenses being generated. So you can see we do have multiple failure login, same name, admin up over here. So from which particular source we do have, you can see 1 minute 43 seconds ago, this event has been generated. Let's open this one and let's read about this one. So multiple login failure preceded by login failure by success by a same username. This Ironman detected, this is some a custom rule which I have created, right? So containing the user failure and all, you can see I do have the source IP, destination IP. Since it's the source IP, it's looking from China. You can see that up over here, right? So I can see total number of events which does have these particular fail login attempts, right? I can try to find out more information about it, that which was my internal server and how it basically is being used. The top five categories, all the events which were part of this offense, right? And we can read all these things. Now I want to know that which rule basically created this particular alert or offense. What I can do, display rules. So these were the rules where things were matching, and it was basically things were matching and we were basically using this one up over here, right? Because of these rules this offense was being generated. Now let's say this one, let's read this one, multiple logon failure for single username. So what does it say? Apply multiple login failures for single username on events which are detected by local system, and when event matches any of the following authentication failure. So there is a category with the name of authentication failure, right? Where they might have put multiple different types of authentication failure, FTP, SSH, or SMB, or multiple different types of authentication failure they have put it up. When event matches that, it is one of the authentication failure, and when at least 10 events are seen with same username in 5 minutes. So from 10 events from same username showing that events are failing, if it happens like this, it will be showing us the results up over there. So because of this rule, when same username, remember this one, there was same username, admin going back and back again. When multiple events were being pushed, right, with same username, failed attempts were being pushed, it generated the alert for us up over there, right? Because that's what our rule basically says. So that is just a small preview of, guys, IBM Qradar, how you can create your log activities, you can generate the offenses, and you can read the offenses on a simpler basis. One more, last, our small topic with WireShark, right? So let's basically start it again. So WireShark, it's your packet capturing, or you can say packet sniffing. Some people do call it packet capturing, some people do call it packet sniffing, some do call it protocol analyzer, some do call it packet capture analyzer tool, right? So that's what Wireshark is. All those people who might have used Wireshark, you might have seen Wireshark files in these particular formats. That will be .cap, .pcap, or .pcap ng, right? And all those people who have installed Wireshark on Windows, you guys might have seen that Wireshark does install something like WinPcap or libpcap, or I would say NCAP type of things, right? So these are the libraries of Wireshark. So Wireshark is basically just one tool which basically captures your network traffic. I would say network traffic capture tool is it is, and we can use it for capturing our network traffic. So coming back to Wireshark, you can see this is how it looks like. Let's say I go through capture. I select one of my interfaces where I want to capture the network traffic, and you can see there are three different panes, right? You do have pane 1, pane 2, and pane 3, right? So I'll just give a name through all of them. Like that's what we do call them in professional terms. The first one you will see lots of packet, right? So that's why we do call it as packet pane. The second one which you will see up over there is what something we do call as frames. Every packet does have a frame. So that second one basically shows the frame of each packet. That's why it's frame pane. And third one is basically your data representation because it represents your data in ASCII and hex format. So can you see over here the packets are being captured, right? Over here for each packet, let's say I select this packet, I can see frames up over here. Now let's say I do see this packet, I can see frames up over here. Now over here, what if I do surf internet, right? Let's say http demo.testfire.net. Can you see over here in my currently captured traffic, it would be involving entire network traffic capture, right? Let's say I just filter around HTTP up over here. So I can put this filters up over here. WireShark support 3000 plus different types of filters up over here. So you can see those parts up over here. So demo testfire.net. Let's say I just try to sign in up over here. I'll give my username and can you see I'm just logged in, right? As admin user. Now let's see all these details with WireShark. This entire traffic capture details with WireShark. Now I do know that it was a HTTP traffic. That means in plain text I will be able to view it, right? So in case if you want to go for let's say FTP, you can see FTP. You want to go for particular IP address, you can type ip.addr equal 192.168.1.42 for example. So all the traffic which will be having source or destination address like either source or destination as 1.42, it will pick it up. If you want only the traffic which is on your system as a destination coming towards your system, so you can see all the traffic which was coming towards your system. So out of 9093 packets, 4507 packets are being coming towards your system. If you want to see packets which have started from your system as a source, you can see 4255 packets are mentioned up over here, right? So this is how guys you can use filters up over here, right? This is how you can use multiple different types of filters. You search SMB, you do search telnet. So any sort of protocol you want to search, search it up over here. You want to go for IP addresses, go for IP addresses. You want to go for HTTP method. You can see HTTP chat, BAT, connection, content, cookie, date, host, all of these things. You guys can see it up over here, right? Let's say HTTP response equal 200. So only the packets which will be having HTTP response 200, you will be able to see those particular packets over there. Understood, team? So that's how Wireshark filters works, right? Now this particular filter, I have added a username up over there. Do you guys believe that I have done that? Because remember on the browser, I logged in into this part. Now I want to see, since it was a not secure traffic, HTTP traffic, with Wireshark, I want to see that username and password. How I can do that? What do you say? One thing which I'll give you the info is, I'll search around HTTP traffic. Now in HTTP, I'm getting 65 packets. Out of 65 packets, which packet should have the answer? Can you guys see up over here? Every single packet does have some details, right? So can you see there is a HTML URL encoded form on top up over here. If I just open it up over here, it says that Qradar get current date time up over here. So that is something from Qradar because my Qradar tab was also open up over here, right? So it was containing this much info. Since I do know that there is an HTML form which was being sent up over here also there is something, some sort of media type over there. All these informations are there. So since I do know that URL encoded form is there, and the part where I did entered username and password, that was also a form, right? Username and password form. So how I can do? Instead of get and post, I'll show you how you can do. Of course, you can go for get method, you can go for post method, but whenever you do add something to the URL in terms of HTTP, you add a form, it's being encoded into the URL. So you can just type an URL encoded form. So it will filter around your traffics up over here. Now, of course, you do not want something for Qradar, right? So let's leave Qradar up over here. And there is this something which says that post do log on up over here, right? Application form. So let's look around up over here. Can you see the UID was admin? The password is. Now again, over here, same username and passwords are there. So I'll just filter around HTTP, right? And I do know that I can go for URL encoded form. And once I do that, I'll do get this packet, and this is where I'll get email and password, right? If anyone is transferring the username password in plain text with this packet capture, we can get the details. Now what are other ways through which I can get it? I can just press Control F. Control F will be bringing this particular string value in front of me, where I can look into the packet details and I can search for the words like password or pass, something like this. So over here, it will show you the results that with this word pass, you do have username and password, right? Over here, let's say I want to search something for Google, anything which does contains Google. So I can try to find it. If there will be anything, it will show it to back to us. Let's say I do search DRDO, find. So wherever DRDO will be written, it will bring out those results. Can you see this? So wireless packet capture possible in this tab? Absolutely. So WireShark does support wireless. Can you see this wireless? So if you do have a Wi-Fi traffic, you want to basically, first of all, you should be finding your Wi-Fi. Since it's my RDP machine on cloud, so I do not have any Wi-Fi up over there. But if you do have Wi-Fi at your place and you just to check it, you'll get the BSS ID and all those things. You can select the one and you can choose the one on which you need to monitor. So NetFlow basically, I would say, is a system or which is being created by Cisco, right? Which basically monitors traffic from one end to another end. Let's say from my system to Facebook, if I am connected, NetFlow will be monitoring each and every packet from my system to the Facebook server, and it will be collecting all that particular data, right? We do have WireShark up over here. NetFlow basically helps us to collect data. It helps us to sort, analyze, same things. So difference between NetFlow and WireShark, I'll just put it in this way that WireShark is something which is more easier and hacker centric tool where you can find out certain activities. Let's say I want to see if there was any sort of image being transferred in this, right? So what I can do is file, export objects, HTTP. I can see what sort of HTTP objects were being transferred up over here. So there was a application UTF-8 form, text HTML file. So anywhere where there will be anything, I will be able to see it up over there. So both of them are good at their ends. NetFlow is more of the enterprise approach, and Wireshark would be something which will be merely used as a tool to do the packet traffic capture analysis, right?